Have you ever wondered how those thick power cables that run beneath our streets are actually laid underground? I mean, it's not as simple as just digging a hole and dropping them in. The reliability of an underground cable network depends a lot on how properly the cables are laid and how carefully the fittings like cable end boxes, joints, and connectors are attached. If this work isn't done properly, even the best quality cable might fail before its time. Now, there are mainly three methods of laying underground cables: direct laying, draw-in system, and solid system. So let's uncover what really happens beneath the surface. Let's start with the direct laying method. This is the simplest and cheapest method, and that's exactly why it's so widely used in modern practice. Imagine a trench about 1.5 meters deep and 45 centimeters wide. First, we lay down a bed of fine sand, about 10 centimeters thick. Then, the cable is placed over this sand bed, and finally, another 10 centimeter layer of sand is added on top. Now, why sand? The sand layer prevents moisture from the soil from reaching the cable and protects it from decay. Once the cable is nicely tucked in, it's covered with bricks or concrete slabs to protect it from any mechanical injury. You know, like if someone's digging nearby or heavy vehicles pass above it. And if more than one cable is to be laid in the same trench, then at least 30 centimeters spacing is maintained between them, either horizontally or vertically. This spacing helps prevent the heat from one cable affecting the others and also ensures that if one cable develops a fault, it doesn't damage the rest. To further protect the cables from corrosion and electrolytic action, they're wrapped with bituminized paper and Hessian tape. Now, this method surely sounds simple, but what are its strengths and weaknesses? Let's first appreciate the good side. Direct laying is not only cheap and simple, it also provides excellent heat dissipation. The sand and the open trench design help the heat generated in the cable escape easily. It's also a clean and safe method, since the cable remains invisible and well protected underground, free from external disturbances. But here comes the catch. If someday you need to extend the load or replace a cable, you'll have to dig the whole trench again. That's expensive and time-consuming. Also, making alterations in this cable network is not at all easy. Maintenance costs are quite high, and finding the exact location of a fault can be difficult. Moreover, it's not suitable for congested urban areas where digging trenches is a nightmare. So, if you were in charge of laying cables in a crowded city, would you go for this method? Tell me in the comments. Now, let's move to the second method, the draw-in system. Here, instead of directly burying the cables in the ground, we first lay underground conduits or ducts, which are usually made of glazed stoneware, cast iron, or concrete. Manholes are built at suitable intervals along the cable route. Once these ducts are ready, the cables are pulled or drawn through them from manhole to manhole. That's why the name draw-in system. Usually, several ducts run side by side. For example, 3 ducts might carry the main transmission cables, while 2 carries pilot or relay protection wires. Care must be taken at bends or junctions because sharp curves or long offsets make it difficult to pull the cables smoothly. Also, since the cables here are laid inside protective ducts, they don't need to be armored, but they are wrapped with Hessian and jute to protect them during the pulling operation. Now, this system is quite smart and flexible. Repairs, alterations, or even extensions can be made without digging up the ground. You just open the manholes and pull out or replace the cable. Because the cables are not armored, joints are simpler and maintenance costs are reduced. The ducts also provide strong mechanical protection, so there's very little chance of damage or fault. But yes, good things don't come cheap. The initial cost of installation is very high because building all those ducts and manholes takes a lot of money and effort. And there's another issue. Since multiple cables are grouped closely inside ducts, heat dissipation becomes difficult, reducing their current carrying capacity. Still, this system is excellent for crowded city areas or places where frequent digging would be too costly or impossible, like under roads or buildings. So, if you had to lay cables in a busy metropolitan area, would you prefer this system over the direct one? Finally, let's talk about the solid system, which is quite rare nowadays. In this method, Open pipes or troughs made of cast iron, stoneware, asphalt, or treated wood are dug into the ground along the route. The cable is placed inside these troughs, and then they're filled with bituminous or asphaltic compound and covered over. This system provides excellent mechanical protection, and since the cables are fully enclosed, plain lead-covered cables are usually used here. However, this method is more expensive than direct laying. It needs skilled labor and suitable weather conditions to execute properly. And because of poor heat dissipation inside the filled troughs, the current carrying capacity of the cables gets reduced. That's why, in modern times, this system is rarely used. So, now you know all about the three main methods of laying underground cables: direct laying, draw-in system, and solid system, along with where each is used, their advantages, and their limitations. If you've ever seen roads dug up in your area and wondered what's happening underneath, well, now you know the science behind it. Which method do you think is the most practical for today's cities? Drop your answer in the comments. I'll be checking them out. And hey, if you learned something new today, don't forget to like this video, share it with your friends, and subscribe to Electrology for more easy explanations on power system concepts. Also, check out the join button below. By joining the channel, you can support my work, get early access to upcoming videos, and enjoy some exclusive members-only content. Thanks for watching, and I'll see you soon in the next video. Until then, keep learning, keep exploring, and stay electrified.